Hello, my name is Richard Daly and I'm an application engineer in the Nexperia Power MOSFET team in Manchester. Within many switching applications, designers are faced with the challenges of balancing high efficiency and low spiking. The obvious way to manage this is by using additional components on the board and adding cost and complexity. In this demo, we will show a typical 48-volt DC-DC converter to show the switching and efficiency performance of our NextPower 80 and 100 volt MOSFETs. So for today's demo, we will be performing a 48 volt to 12 volt DC-DC conversion using our NextPower 100 volt product and an equivalent competitor part. The test that we're going to be performing is an efficiency sweep from 2 to 20 amps using a 200 kHz switching. Let's just dive into the PCB board and show what we're going to be demonstrating today. On the left hand side, we have our NextPower 100 volt product, and on the right hand side, we have the equivalent competitor available on the market. First of all, we're going to start testing our NextPower 100 volt product, perform an efficiency sweep, and capture the switch node spiking for the comparison later on. So let's dive into that measurement. So one of the key parameters that we want to capture here is the switch node spiking. However, as we sweep through the loads, switch node spiking shouldn't change. And what we have noticed is that some products at higher loads has higher spiking. What we're going to demonstrate today is capturing the spiking node at 20 amps and looking at the efficiency sweep to compare against our product and the equivalent competitor. So let's have a look at the efficiency sweep. As you can see on screen, we are roughly about 86 amps and we are performing around 96.6% efficiency. But the key area parameter is looking at the 20 amp load. So for a 20 amp load, we are achieving around 48 to 49 volts on the switch node spiking with an efficiency of 96.6%. Now that we have this information, we can switch over to the competitor and see how this performs against theirs. Now that we have changed over to the competitor part, we will be performing the exact same sweep from 2 to 20 amps, ensuring that we've got a fair comparison from their part to our product. So let's do that measurement. What's really important is that we capture the efficiency at the 20 amp load and the switch node at 20 amps, so that we can do a fair comparison between the two. So with a 20 amp load, the efficiency is 96.4% and the switch node spiking is 54 volts. So now we know that the efficiency is comparable. Nexperia is slightly higher, but it's still within the same range. Let's dive more into the switch node, where the key benefits of this technology really proves. So if we look at the switch node spiking between the NextPower 100 volt products and the equivalent competitor part, we can see that we almost have a 6 volt difference on the switch node spiking. This could really help with the EMC testing. The demo uses the 100 volt 4.3 milliohm device from our portfolio of NextPower 80 volt and 100 volt power MOSFETs, housed in our enhanced LFPAC 56E package. With an extensive portfolio of products in our thermally and electrically high-performance LFPAC 56 range, the 80 and 100 volt MOSFETs are our latest silicon technology and are ideal for high switching applications, including AC-DC, DC-DC, and motor control. NextPower 80 volt and 100 volt MOSFETs feature QRR down to 50 nanocoulombs, resulting in low IRR, low voltage spikes, and reduced ringing. Additionally, the reduced I2R losses and high ID max makes these MOSFETs suitable for the most challenging, high switching, and high reliability applications. The innovative LFPAC package is 100% avalanche tested, offering low package inductance and resistance, as well as excellent robustness and board level reliability due to its flexible leads. Thank you for watching. For more information, go to nexperia.com.